Good afternoon everyone. Today I am going to discuss about the grid and cloud computing subject, Unit 4. Coming to the topic, main components on programming model. So this is the diagram of main components and programming model. So in this diagram we are having the Globus toolkit version 4. So we can say it is a GT4, and in this we are having community authorization, data replication and community scheduler framework, grid telecontrol protocol, web MDS, Python WS core, CWS core, Java WS core, C common libraries, extensible input output. So these are the different components of the programming model which we have used. Okay, so in this it is an important to realize that the Globus toolkit includes a lot of other components which help us to build a grid system. So the Java WS core, the Java web server core component is essentially interesting because it is the base for most of the web servers components, so that we do not need to have in-depth knowledge about this Java web server core to use many GT4 means Globus toolkit 4 components like resources, access and management, MDS, etc. If we want to build a grid system that integrates all of these components with our own services, we will need to know about Java WS core to actually glue all those services together and a program our own services. So this is called the main components and programming model. So in this dotted line, so here we are having a rectangular box. This rectangular box is called core GT component public interface frozen between incremental release best effort support. So this is the in rectangular form. In the dotted rectangular we are having, so in the dark dotted we are having, so that is the contribution uh, preview public interface may change between incremental release. Okay, so this is the dark dotted line rectangular box, and we are having the small dots rectangular box. So this is called deprecated component not supported will be dropped in a future release. So this is called the small dotted line. Okay, so next coming to the introduction to Hadoop framework. So Apache Hadoop and the Hadoop ecosystem. So in this this Hadoop is the best known for Mapreduce, and it is distributed file system. So HDFS. So in this we having renamed from NDFS. Okay. So and Mapreduce is a programming model for data processing. So this model is a simple, not too simple to express useful programs, not to useful programs. In the Hadoop can run MapReduce programs written in various languages, like the same programs expressed in Java, Ruby, Python and C++. So in this MapReduce comes into its own large data sets. So okay, own large data sets. So the MapReduce programs inherently parallel, so putting very large scale data analysis into the hands of anyone with enough machines at their disposal. So MapReduce comes into its own for large data sets. So it starts by looking at one, analyzing the data with Hadoop. So to take the advantage of the parallel processing that Hadoop provides what to express our query as a MapReduce job. After some local small scale testing, we will be able to run the clusters of machines. So okay, so next coming to the diagram, this is the diagram we are having. So in this we are having applications, query. In the applications we are having reporting, statistics, analytics, queries. Okay, and after that we are having the orchestration framework. So HBase, Flame, Joop Keepers. So okay, data access framework. So in this we having different living beings, and network data storage framework, that is HDFS, and data processing framework Mapreduce. Next JVM we are using Java Virtual Machine. Next operating system Linux and Dell. Okay, Dell servers. Next we are having the backup recovery, deployment, security management. Okay, so this is the diagram of the Apache Hadoop and Hadoop ecosystem. Okay, so next coming to in this we having some distributed with some centralization. So main nodes of clusters are most of the computational power and storage of the system lies. So main nodes run task tracker to accept and reply to Mapreduce task, and also data node to store needed blocks closely as possible. The central control nodes runs name node to keep the track HDFS directories and files, and job tracker to dispatch compute tasks to task tracker. So written in Java, also supports the Python and Ruby. Okay, next coming to map and reduce. What is mean by map and reduce? So map reduce works by breaking the processing into two phases, the map phase and the reduce phase. So each phase has key value pairs as input and output, the type of which may be chosen by the programmer. The programmer also specifies two functions, the map function and reduce function. So okay, so anatomy of the Mapreduce job run, you can run a Mapreduce job within a single line of code. So the job client dot run job. Okay, it is very short, but it conceals a great deal of processing behind the scene. This uncovers the step of Hadoop takes to run a job. So in this we are having some process, whole process. At the highest level there are four independent entities we are having. Okay, first entity is the client which submits the Mapreduce job. The client should be submit the Mapreduce job, and the job tracker which coordinates the job run. The job tracker is a job application whose main class is job tracker. Okay, so whose main class is a job tracker. The task tracker which runs the task that the job has been split into task trackers or Java applications, so whose main class is task tracker. The distributed file system, normally HDFS, which is used for sharing job files between the other entities. So this is called the entities of the these are the four entities of the highest level. So next coming to job submission. So how we are submitting the job. So the run job method on job client is a convenience method that creates a new job. So okay, so we are running the job method on job client in a convenience method that creates a new job client instance and calls the submit job on it. This is the first step. We have to submit the job. Run job polls the job's progress once a second and reports the progress to the console if it has changed since the last report. When the job is complete, if it was successful, the job counters are displayed. Otherwise, the error that caused the job to fail is logged to the console. The job submission process implemented by job clients that submit the job method does the following process. So we ask the job tracker for a few job IDs by calling get new job ID on job tracker. This is the step 2. We are checking the output specifications of the job. For example, if our output directory has not been specified or it already exists, the job is not submitted and an error is thrown to the Mapreduce program. So the input splits for job. If the splits cannot be computed because the input part do not exist, for example, then the job is not submitted and an error is thrown to the Mapreduce program. So copy the resources needed to run the job, including the job jar file, the configuration file, and the computed input splits the job trackers file system in a directory named after the job ID. So the job jar is copied with a high replication factor, that there are lot of copies across the clusters for the task trackers to access when they run the task for the job. This is the step 3. So next we tells the job tracker that the job is ready for execution by calling and submitting the job on job tracker. This is the step 4. So this is called the job submission. Next, job initialization. So when a job tracker receives a call to its submit job method, so it puts it into a internal queue from where the job scheduler will pick it up and initialize it. So initialization involves creating an object to represent the job being run, which encapsulates its tasks and bookkeeping information to keep track of task status and progress. So this is called a step 5. To create the list of tasks to run, the job scheduler first retrieves the input splits and computed by the job client from the shared file system. So this is the step 6. Okay, so in this job initialization, we tells the job tracker that the job is ready for execution by calling submit job on the job tracker. This is the step 4, which we have seen in the previous. So next, coming to so in this we are having the input splitting. So task assignment, input splitting. Input means whatever the input we are giving, that is splitting into number of tasks. So the task assignment, what does the task assignment performs? So the task trackers run a simple loop that periodically spends heartbeat method calls to the job tracker. So the heartbeat tells the job tracker that a task tracker is alive, but they also double as a channel for message. So the job tracker will message, and as a part of the heartbeat, a task tracker will indicate whether it is ready to run a new task. So and if it is, the job tracker will allocate it a task, which it communicate the task tracker using the heartbeat return value. It is the step 7. So before it can choose a task for the task tracker, the job tracker must choose a job to select the task from. So this is called the task assignment. Next, task as execution. Okay, so in this now that the task tracker has been assigned a task, the next step is for it run the task. First it localize the job. First it localize the job jar by copying it from the shared file system to the task trackers file system. It also copies any file needed from the distributed cache by the application to the local disk. Second, it creates a local working directory for a task and unjars the content of the jar into this directory. At the third point, it creates an instance of task runner to run the task. The task runner launches a new Java virtual machines in the step 9 to run each task in step 10, and any bugs in the user defined map and reduce the functions do not affect the task tracker. So next is job completion. So okay, now do not affect the job do not affect so do not affect the job tracker, job task tracker. So next it has possible to reuse the JVM between the tasks. The child process communicates with its parent through the interface. This way, it informs the parent of the task progress every few seconds until the task is complete. So, next coming to job completion, when the job tracker receives a notification that last task for the job is complete, it changes the status for the job for a successful. Then, when the job client polls for status, it learns that the job has completed successfully. So it prints the message to tell user and returns from the run job method. So next this is called job completion. Next is Java Mapreduce. So having run through how the Mapreduce program works, the next step is to express it in code. So we need three things: a map function, a reduce function, and some code to run the job. So a map function is represented by an implementation of mapper interface which declares a map method. So next, analyzing the data with a Hadoop. To take advantage of the parallel processing that Hadoop provides, we need to express our query as a MapReduce job. After some local small scale testing, we will able to run the cluster of machines. So this is called analyzing the data with Hadoop. Next, Hadoop library from Apache. So Hadoop is an open source implementation of MapReduce coded and released in Java. So rather than C by Apache. So the Hadoop implementation of MapReduce uses the Hadoop distributed file system. Hadoop HDFS means Hadoop distributed file system. So as its underlying layer rather than GFS, and the Hadoop core is divided into two fundamental layers, that is MapReduce engine and HDFS. So the MapReduce engine is a computation engine running on top of HDFS, means Hadoop distributed file system, as it data storage manager. The following we having two sections to cover the detail of these two fundamental layers. So next, this is the HDFS. HDFS is a distributed file system inspired by the GFS that organizes files and store their data on distributed computing systems. So HDFS architecture. So in the HDFS architecture has master and slave architecture containing a single name node as a master and the number of data nodes as a workers. So it means I having the one master, so that is called the name node, and I having the number of data nodes, that is called slave node. Okay, so DFS splits the file into fixed size blocks. So I have the data, the example 64 MB of data. So I am splitting the data into fixed size of blocks. Okay, that DFS will be split the data into fixed size blocks and store them into the workers. So workers means what here? Data nodes. So data nodes is called, in the data nodes whatever the information I have, that information is fixed, splits into split the file into fixed size blocks. That all stores them on the workers, that is called data nodes. So the name node, that is master, also messages the file systems metadata and namespace. Okay, so in such systems, a namespace is a area maintaining the metadata, and metadata refers to all the information stored in the file system that is needed for all overall management of all the files. So in this we having the HDFS architecture we said now. So this is the architecture. So in this architecture we having the name node here. So we are having the data nodes. So what is mean by name node we have said here. So name node it comes under the master node, and here name node is a master node, and data, here we are having the data node 1, 2, 3. So these nodes, name node will be a single, that is called master node. Slave nodes will be number of data nodes will be taken as a workers. So these are the workers and these are the number of nodes. I am taking 1 2 3 data nodes here. These nodes are called the slave nodes. Okay, so whatever the information we are having, they what said, so our having the data. So just a reminder, this is a 64 MB of data, so that can be splits into that file will be splits into fixed size blocks. So this is the box. So this is the block 1, block 2, block 3 and block 4. So the file is divided into blocks. So whatever the data I having, the data will be divided into equal number of blocks. That is every block. For example, 64 means 8 8 8 8 8. Okay, so this like so every block having the same size of data. Okay, after that what we are doing here, so after distributing the data, so okay, so the data will be the data will be divided. The name node is the name node in the metadata stores all the information regarding the location of input splits blocks in the data nodes. So whatever the information present in the name node, that all things are present in the data node. Okay, so the data node is the metadata stores. It will be stores the metadata information. It is a Java program. So in this we having it is a direct execution. So it is a job tracker. Okay, executed the program. It is a job tracker, executed the program. Each data node, usually one per node in a cluster, manages the storage attached to the node. Okay, so each data node is responsible for storing the retrieving its file blocks. So what you are seeing in the name node, actual data in the data node. So in this data node, so that in this we having no restrictions to no restrictions. So it has it is too expansive. Servers will can also cheaper servers also, that processing can also be that processing the data in the distributed mode. We work the work together. So the data node have actual the data node will have actual data with 100 like 100 grams of files. That file data can be divided into 4 blocks. You think here in the data node we having 64 GB, that is divided into equal number of blocks, 4 blocks I am. So the 4 data blocks stored in the data node, the 4 blocks of data is stored in data node, is called that is called the slave nodes. Okay, so the name node that is 3 slave nodes is constantly communicate with each other, and the data node so the data node also think that it is whatever the information available, that data also the data also present in the name node. Okay, so in this HDFS, so what is the HDFS? HDFS is the Hadoop distributed file system. So in this Hadoop every, so here every block, here block 1, here there, here block 2 is there, here block 3, block 4. So we don't think that only block 1 can receive the block 1 data and block 2 only receive the block, not like that. Every HDFS having that data. HDFS can have the block 2, block 3 of data, and HDFS of data node 2 that can have the block 4 and block 1 data. So whatever the data, that data will be replicated with each other. The replication of blocks in HDFS. Okay, so the data is copied in different machines. So whatever the data we are storing, that can be replication can be done in all the HDFS. So we don't say that only one block of data is stored in the HDFS. Only block 1 is stored in the HDFS. In block 2 in HDFS that can have only block 2, not like that. So whatever HDFS we are having, every can store whatever the data can be sended. The data will be replicated with each other. Okay, so if one machine data node is corrupted, then its data will be available at the another machine. So if one machine is damaged or any corruption will be occurred in this block, so remaining the data will be how the block 1 data, block 2 data. So what I am saying in HDFS, So this is the first block 1, and block this is the HDFS 1, HDFS 2, and HDFS 3. HDFS is there. One of the HDFS, I mean Hadoop distributed file system, is corrupted during to any problem. So remaining 2 HDFS will have the complete data, so it doesn't corrupted. Due to this corruption of HDFS, remaining 2 it does not be corrupted, so data will be available in this. If the name node will be corrupted, complete this processing will be corrupted. Okay, this will be damaged. So okay, now so the Mapreduce program executes this will be performs the Mapreduce program and executes the data. Okay, so this admin, so it will be go to the admin, it will be goes to the admin, and it will be configure the data, and data blocks into number of splits here. Okay, so this will be distribute the data to the data node, and whatever the data is there, that can be available in the name node also. Okay, so this is the working of working of the HDFS. Okay, so next coming to so HDFS features. So in the distributed file system have special requirements such as performance, scalability, scalability, and concurrency control, concurrency control, fault tolerance, and security requirements to operate efficiently. In this HDF efficiently. So because HDFS is not general purpose file system, it is execute specific types of applications. It does not need all the requirements of the general distributed system. So for example, security has never been supported for HDFS system. So the following highlights 2 important characteristics of HDFS that distinguish it from other generic distributed file system. So this is the HDFS features. Next, HDFS fault tolerance. So one of the main aspects of HDFS is fault tolerance characteristics. So Hadoop is designed to be deployed on the low cost hardware. By default, a hardware failure in this system that considered to be common rather than exception. So Hadoop considers the following issues to fulfill reliability requirements of the file system. So block replications to reliably store the data in HDFS. File blocks are replicated in this system. So I told that in the HDFS, we having 3 HDFS there in the diagram. So in the previous diagram, so whatever the information we have stored the data, reliably store the data in HDFS. So the data will be replicated remaining systems also. Okay. So in other words, the HDFS stores a files as a set of blocks, and each block is replicated and distributed across the whole cluster. So this replication factor is set by the user, and 3 is 3 by default. Okay, so the replica placement of replicas is another factor to fulfill the desired fault tolerance in HDFS. So storing the replicas on different nodes, that is a data node located in different racks across the whole cluster, provides more reliability. It is sometimes ignored as a cost of communication between 2 nodes in different racks, relatively high in comparison with that different nodes located in the same rack. For example, default replication factor of 3 HDFS stores 1 replica in the same node. The original data is stored one replica on different nodes but the same rack, and 1 replica on different node in different rack to provide the 3 copies of the data. Okay, so I told that I have 3 HDFS. In every HDFS, the information will be stored. Okay, same data will be copied. So it means replicated with each other. Any of the HDFS is corrupted, the remaining 2 will be in active state only. So it doesn't have corrupted. Okay, so the heartbeat and block report message and reports are periodic message sent to the name node by each data node in a cluster. So whatever the in the diagram, so in that architecture, so whatever the messages are have in the block, that can be reported to the that message will be sent to the name node, and name node will be sent to the each data node in the cluster. Okay, so the name node receives such messages because it is a sole decision maker of all the replicas in the system. So HDFS high throughput access to large data sets files, because HDFS is primarily designed for batch processing rather than interactive processing. Data access throughput in HDFS is more important than latency, because application HDFS typically runs on the HDFS typically have large data sets. It will have the large data sets, individual individual files are broken into large blocks, that is 64 MB, to allow HDFS to decrease the amount of metadata storage required per file. So this provides two advantages. List of blocks per file will shrink as the size of individual blocks increases, and by keeping the large amount of data sequentially within a block, HDFS provides fast streaming rates of data. So in this HDFS we have some operations. In HDFS it controls the control flow of HDFS operations, such as read and write, can properly highlight the roles of the name node and data node in the managing operations. So reading a file to read a file in HDFS Hadoop distributed file system, a user sends an open request to the name node to get the location of the file blocks. The number of addresses depends on the number of block replicas. After the first block is streamed from the respective data node to the user, they establish the connection and terminated, and the same process is repeated all the blocks of the requested file until whole file is streamed to the user. So we write if that is reading file. Now writing the file, to write a file in HDFS Hadoop distributed file system, a user sends a create request to the name node to create a new file in the file system namespace. The first block of the file is written to an internal queue termed the data queue, while a data streamer monitors its writing into the data node. So the block is forwarded to the second data node by the first data node. The process continues until all allocated data nodes receives a replica of the first block from the previous data node. So this is the operations of the HDFS. Okay. So next, coming to architecture of Mapreduce in Hadoop. Okay. So the topmost layer of Hadoop is the Mapreduce engine that manages the data flow and control flow of the Mapreduce jobs. So over distributed computing system, it shows the Mapreduce engine architecture cooperating with HDFS. So the Mapreduce, in this Mapreduce engine also has a master and slave architecture, consisting a single job tracker as a master and the number of task trackers as a slaves workers. So HDFS and Mapreduce architecture in Hadoop were boxes with different shadings, refer to different functional nodes applied in different blocks of data. So each task tracker node has number of simultaneous execution slots, each executing either a map or a reduced task. Slots are defined as a number of simultaneous threads supported by CPU of the task tracker node. So in this task tracker node, so in this task tracker node with n CPUs, we have the n CPUs and each supporting m threads. Each supporting m threads has m into n simultaneous execution slots. It is worth noting that each node blocks processed by one map task running on a single slot, single slot. So the task tracker manages the execution of a map and or a reduced task on a single computation node in a cluster. HDFS and Mapreduce architecture in Hadoop I told that they are boxes with a different shading, refers to the different functional nodes, applies applied to the different block of data. Okay, so next coming to map and reduce functions. Map and reduce functions. So in the map and reduce function Mapreduce works by breaking the processing into two phases. So the map phases, one is map phase, another is reduce phase. So each phase has key value pairs as input and output, the types of which may be chosen by the programmer. The programmer also specifies two functions, that is map function and reduce function. Okay, so in this the input to our map phase is a raw NCDEC data. We choose a text input format that gives us each line in a data set as a text value. So the map function is just a data preparation phase, setting up the data in such a way that a reducer function can do its work on finding the maximum temperature for each year. So the map function is also a good place to drop bad records. So here it filter our out temperature that are missing, suspect, or erroneous. So next coming to Java Mapreduce. Having run through how here the Mapreduce program works. The next step is to express its code. We need three things: a map function, a reduce function, and some code to run the job. Okay. To run the job, the map function is represented by implementation of mapper interface, which declares map method. So in this having the program, we are implementing the 4 map functions. So this is the program I am having. So this is the class. So I am providing the map method here. Mapper extends to Mapreduce base. So implementing the mapper. Okay. So this is the small example program of this Mapreduce. So I have in this mapper interface. So mapper interface is a generic type with 4 formal type parameters that specifies input key, input value, input key, input value, output key, and output value type of the map function. Hadoop provides its own set of basic types that are optimized for network serialization. These are found by organization.apache.hope.io package. Here we use a long writable which corresponds to the Java long text. Long text, that is like Java string, and int writable. Here we are using the writable and int writable like Java integer. The map method is passed a key to a value. We convert the text value containing the line of input into the Java string. So that uses the substring method. Okay, in method to extract the columns we are interested in. The map method also provides an instance of output collector. To write the output to in this case we write the year of the text object since just using the key, and the temperature is wrapped in an int writable. So we write an input record only if the temperature is present, and the quality code indicates the temperature reading is okay. So we reduce the function is similarly defined using a reducer. Okay, and this is the using the reducer. We are using the reducer. So whenever I am using the reducer map, this is the example of the reducer. So in this we are having the, so in this this is the another example program. So in this we are using the maximum temperature reducer for maximum temperature. This is the example for that. And in this a job conference object forms the specifications. So sorry, again the four formal type parameters are used to specify the input output type. These types input and output types. This type for reduce the functions. The input types to reduce the functions must match the output type of the map function. Test and test and in writable, and in this case the output type of the reduce function are test and in writable for a year, and its maximum the third piece of code runs the Mapreduce job. Okay, so next we are having the third example. So in this we are having all the organization dot apache dot hadoop dot in writable. So these are the example to reduce the reduce program. Okay, so next coming to another example. This is the application to find the maximum temperature in the weather data set. Okay, so in this we are having the it gives you control over how the job is run. When we run the job on the Hadoop cluster, we will package the code into jar file, so which Hadoop will be distributed around the cluster. Rather than specifying the name of the jar file, we can pass a class in a job constructor, which Hadoop will use the locator use to locate the relevant jar file by looking for a jar file containing this class. Having constructed a job conference object, we specify the input and output path. Input path is specifying by calling the static and input path method on file input format, and it can be a single file, a directory, or a file pattern. As the name suggests, add input path can be called more than once to use the input from multiple paths. So that is called the input. Next input path. Next output path. Output path is specified by a static set output path method on file output format. It specifies the directory where the output files from the reducer functions are written. So the directory should not exist before running the job. A Hadoop will complain and not run the job. These precautions to prevent the data loss. And next we specify the map and reduce type to use the set mapper class and set mapper class and set reducer class methods. The set output key class and the set output value class methods control the output types for the map for the map and reduce functions, which are often the same or in our case. So if there are different then the map output types can be set using the methods and set map output key class and set map output value class. The input types are controlled the input format, which we have not explicitly set. We are using the default test input format. Okay, so this is the example diagram. So next we are having the data flow. So what is mean by data flow? A Mapreduce job is a unit of work that the client wants to be performed. It consists of input and Mapreduce program and configuration informations. So Hadoop runs the job by dividing into tasks, of which there are two types, map task and reduce task. There are two types of nodes and that control the job execution process. A job tracker and a number of task trackers. A job tracker coordinates all the jobs runs on the system by scheduling the task to run the task trackers. Task tracker runs the task and send the progress report to the job tracker, which keeps the record overall the progress of each job. If the task fails, the job tracker can reschedule it on a different task tracker. Hadoop divides the input to a Mapreduce job into fixed size pieces called input splits or just splits. Okay, input splits are just splits. Okay, so Hadoop creates one map task for each split, which runs the user defined map functions for each record in the split. Okay, for most jobs, a good for having many splits means the time taken for process the each split is small compared to the time to process the whole input. If we are processing the splits in parallel, the processing is better load balanced. If the splits are small, the faster machine will be able to process proportionally more splits over the course of the job than slower the machine. Even if the machines are identical, failed the process or other jobs running concurrently make load balancing desirable, and quality of load balancing increases as splits become more fine grained. Okay, in this on the other hand, if the splits are too small, managing the splits and map the task creation beings to dominate the total job execution time. Most jobs, a good split size tends to be size of the HDFS block, that is 64 MB by default. This can be changed for the cluster or specified when each file is created. Hadoop does its best. Hadoop does it best best to run the map task on the node. So the input data resides in HDFS. This is called the data locality optimization. Okay, map tasks write their output to the local disk, not the HDFS. Okay, so if the node if it is reduce the task to produce the final output, once the job is complete, the map output can be thrown away. So storing it in HDFS while replication would be overkill if node running the map task fails before the map output has been consumed by the reduced task. Then Hadoop will be automatically run. So this is called the workflow. Okay, so data flow. So thank you. In the next class we will discuss the next topic, that is specifying input output parameters. So thank you everyone.